Today we'll be looking at mechanical advantage of the simple machines that you've been working with. We're doing this math practice now so that when you go on to the virtual labs for simple machines, you will be very familiar with how to calculate mechanical advantage. Make sure you use this PowerPoint when you're doing your actual assignment. The PowerPoint gives you review terms like we're going to go over soon, as well as some practice problems and the equations that you will need when you solve mechanical advantage. So first, let's review the types of measurement that we're using when we solve guess problems for mechanical advantage. First one is length. In the equation, you would see length with a lowercase l. The unit for length is either going to be in meters or centimeters, and the abbreviation for those are lowercase m or cm. If you were working with the simple machine wheel and axle, you would be looking at the radius of the wheel and the radius of the axle. So the mechanical advantage equation for a wheel and axle will have a lowercase r for radius. And those are measured the same way as length. If you were using an inclined plane, you would need to know the height of the inclined plane in order to find its mechanical advantage. In an equation, height is represented with lowercase h, and just like length, it's measured as meters or centimeters, and those are the abbreviations. Now, if you were looking at something like a lever or a pulley, you could be measuring force. If you remember, force is a capital F when you see it in the mechanical advantage equation. Force is measured in newtons, which is represented with a capital N. And lastly, you need to know the variable for mechanical advantage, which is MA. Remember that mechanical advantage is a pure number. It does not have a unit, and therefore it does not have a unit abbreviation. So when you find mechanical advantage, you will not write any units after that number. Now that we've reviewed these terms, let's move on to some information about mechanical advantage. Mechanical advantage tells us how helpful the machine is. The higher the number, the more mechanical advantage you have. In mathematical terms, mechanical advantage is telling you how many times the input force is multiplied. Remember, you are the input. The input is the same as the effort. You are doing the input force, or you would be calculating possibly input distance, and this is all what is done by the person using the machine. The output is the same as the word resistance, and this is what the machine does to the object. So you are the input, the machine is the output. Let's move on to the equations you'll need to know to calculate mechanical advantage for various simple machines. First equation says MA equals FO divided by FI. This stands for output force divided by input force. You might use this equation if you were measuring the mechanical advantage of a lever or a pulley. The next is mechanical advantage equals LI divided by LO. This stands for input length divided by output length. And again, you could use this if you were measuring the mechanical advantage of a lever or pulley. The next is mechanical advantage equals RI divided by RO. Notice, it's very similar to the equation before it, input divided by output. The reason it's similar is because this stands for the radius of the input divided by the radius of the output. We've learned that if you are measuring a radius, you have to be measuring a circle. What kind of simple machine is made of two circles? A wheel and axle, of course. And we also know that a wheel and axle is just kind of a modified lever. So if you're measuring length or radius, it's the same equation, just depending on which kind of lever you're using. A wheel and axle is a modified lever, or a standard bar lever. And lastly, you will be calculating the mechanical advantage of an inclined plane, which is length divided by height. So the length of the ramp divided by the height of the ramp. Remember, height goes straight up and down, and length is the distance from the ground to the top of the ramp. Just so you're aware, I'm giving you these page numbers, which is where you will find these equations in your textbook. This is the blue Motion and Forces textbook. And next to these equations, or near these equations, there's a picture of the type of simple machine that you would use with each of these equations. Okay, once you have that information, and if you didn't write this down, you're going to need to have this video handy so that you can go back to these equations. Let's move on to some practice problems. Our first practice problem says, what is the mechanical advantage of the wheel and axle? And notice it gives us information. It says here that the wheel has a radius of 45 centimeters. This is the wheel. You are turning the wheel. The machine is turning the axle. And it says the axle has a radius of 9 centimeters. So, if you are turning the wheel is the same as the input. The axle would be the same as the output. Let's move on to our actual guess information. So, we know we are looking for mechanical advantage. So let's fill that in first. If we're talking about a wheel and axle, you can tell from either your book or the information on the previous slide that mechanical advantage is the radius of the input divided by the radius of the output. That means in our given information, we need to know the radius of the input and the radius of the output. You are the input. That means your information is coming, or the information for the input is coming from whatever you would be doing to the machine. The input is the same as the wheel. And the wheel, we said, was 45 centimeters. The machine does the output. Therefore, the output is the same as the axle. The axle, we were told, was 9 centimeters. Remember, when we're talking about radius, we mean the distance from the middle of the circle to the outside edge. That is the radius for any circle. Okay, let's go ahead and substitute. Mechanical advantage equals the radius of the input, which is 45 centimeters, divided by the radius of the output, which is 9 centimeters. If you need it, you can bring up your handy dandy calculator. 45 divided by 9 gives us a mechanical advantage of 5. That is a pretty darn good mechanical advantage. Typically, mechanical advantages are 1 or less than 1. Okay, moving on to our next formula. Moving on to a new type of simple machine. It says if Mr. W is applying 20 newtons of force to this lever, and the lever is applying 80 newtons of force to the box, what is the mechanical advantage of the lever? Before we move on to the guess problem, let's take a look at some information given to us in the problem. So it says here that we're dealing with force. That should give you a clue as to which equation you need to use. We only have one equation that has force in it, and that is going to be output force divided by input force. The output force is done by the machine. This is the FO. The input force, we said, is done by you. That's the FI. So let's move on to the guess problem. It says that the input force is 20 newtons. Mr. W applies 20 newtons of force to the lever. The output force must be what the lever does to the box, which is 80 newtons. Let's see if we can put that into a guess format. we know we're looking for mechanical advantage. We know the mechanical advantage, if we're using forces, is FO divided by FI, which is the same as resistance force divided by effort force. That means in the problem we must be given FO and FI. Output force done by the lever is 80 newtons. Input force done by Mr. W is 20 newtons. Now we can go ahead and substitute. 80 newtons divided by 20 newtons. And if we move down here, mechanical advantage must equal 4. Okay, not bad. We know that the mechanical advantage of the lever that Mr. W used is just a bit less than the mechanical advantage of the wheel and axle we calculated in the first problem. Let's see if we can do this again. This time with a different set of information. It says we now know that the length of the lever from Mr. W's hands, right here, to the fulcrum, right here, is 20 decimeters. And the length from the fulcrum to the box is 5 decimeters. Now, what is the mechanical advantage? Notice here, it's the same picture. It's the same lever, it's the same object, and it's the same person. But instead of giving us forces, the information we're given to use is length. So let's figure out which lengths we're talking about, or distances that we're talking about. The input length, Li, and the output length. Input is what you do, output is what the machine does. The input length would be from Mr. W's hands to the fulcrum. Li is 20 decimeters. The output length is from the fulcrum to the object you're moving. So the output length is 5 decimeters, as we can see here. Now we can move on to the actual guess problem. So once again, we know we're looking for mechanical advantage. We know that the mechanical advantage, if you are given lengths, is input length divided by output length. That means our given information must be the input length and the output length. If we go back, we know that the input length is 20 decimeters and the output length is 5 decimeters. Make sure you use units with every number that is an actual measurement. The only thing you don't have to use units for is the mechanical advantage at the end. Okay, if we substitute into our equation, we need input in the numerator, so that would be 20 decimeters divided by output in the denominator, 5 decimeters. And if you need your handy-dandy calculator, 20 decimeters divided by 5 decimeters is a mechanical advantage of 4. Now if we go back a few screens, when we calculated the mechanical advantage of the lever using force, we found that it was 4. Mechanical advantage when we calculate it using length is also 4. If it's the same setup, if it's the same machine and the same object and the same person pushing on it, then the mechanical advantage is going to be the same no matter how you calculate it. Okay, hopefully this is helpful to you. When you go to actually solve your problems, if you have any questions, make sure you go back to this or send me a message.